We're going to get started a little bit early. I guess it doesn't hurt to have extra time. As people are filing in, I'm sure it'll be okay. I'll take questions at the end anyway. Hello, welcome to the food court menu of APIs, a GraphQL introduction. I will be your host today. My name is Shen. I am a former developer. I used to be we all said we were full stack. Frankly, I was a front-end developer on QuickBooks. And then 4 years or so into my tenure, I switched into developer advocacy. Nowadays, I focus a lot on GraphQL advocacy that encompasses both internally at Intuit as well as externally, such as where we are today at All Things Open. And so I'm here to talk to you today about GraphQL at a beginner level. So let me set some quick expectations. So first of all, I'm going to assume that most of you here know some amount of API basics. You're familiar with REST. We are going to cover GraphQL basics today, but it's a lightning talk, and there's not a lot of time to get into the nitty-gritty, nor am I qualified to teach that, honestly. So this is not a master class, and I'm not here to argue with you that GraphQL is superior to REST. We're not doing Batman versus Superman. This is just purely talking about what is good for certain applications over other applications. So we'll do some like versus stuff at the end, just so you can see where one excels over the other and vice versa. So, you guys hungry? Let's get some food. Okay, I'm going to be using an analogy today. In my work as a developer advocate, I've had to do a lot of actually explaining GraphQL to non-technical people or like total beginner developers, right? And so this is an analogy that hopefully you can take away and use it to shout the phrases of GraphQL to the mountains if you want to. It has worked with my non-technical coworkers, so I hope it will work for you all as well. Let's see. Let's imagine, walk with me for a moment. Let's imagine that it's lunchtime. You're on your lunch break. You head to the nearest food court. And at the food court, you're like, I'm feeling today some pizza as my main course. I think I'm going to pick up some lemonade as like a nice drink on the side. And then maybe I'll have like ice cream because I have a sweet tooth and I'm feeling a little sweet treat today. So you go to each of those booths and you order your food. And each of them gives you like a little buzzer thing, right? The thing that lights up. It goes, bzz, bzz, your food's ready. So you have 3 of those on your hand. You go find your seat or whatever. One by one, the buzzers go off. You get up, you go get your food, and then you're done. Like that's your lunch. You got it in hand. This analogy is what REST is like, right? So you go to each of the endpoints where you want some amount of information. In this case, it's a meal rather than information. And one by one, you get what you need. And you handle it yourself, however you want to handle the ordering, the caching, if you wanted to care about that. This is REST. Now let's imagine the next day. You really like that food court. You're feeling the pizza again. You want to do the exact same thing. You go back to that food court, but they have reorganized a little bit. Things look a little different. Now, in the middle of this food court, there is a cashier, just one cashier. Everyone else's cashiers are gone. It's just the one in the middle. And it turns out that you're supposed to just walk up to this cashier in the middle of the whole food court and order from all of the 3 booths that you wanted to order from, all at once. You place your order. You still want pizza, lemonade, ice cream. They give you one buzzer. You go take your seat. Eventually, the buzzer goes off, and you get all 3 at the same time. That's GraphQL. That's all it is, okay? From a consumption side perspective, this is what GraphQL feels like. The only difference is really that like you just do it all at once. Like everything is centralized in a certain way, depending. We'll talk about that a little more. And you get everything all at once, no more, no less, right? You're not going to over-order, under-order, because you're just getting exactly the 3 things you want. I'm going to extend the metaphor a little bit, right? In many cases, like in the REST scenario, maybe the restaurants previously only sold set meals. So your pizza came with pickles, I don't know. And like you didn't really want your pickles, but you had to take the pickles because it was part of the set. So this is an example this is just the analogy that I have been using, and we'll build on top of it as we go through into more technical details. So at this point, let's start to get just a little more technical about it. So first of all, let me quickly introduce what exactly is GraphQL actually. I've been talking about it, but I haven't actually defined it. So GraphQL is a query language API. It's not a database technology. People see QL and they start going, oh my God, like SQL. But it's not. The services can be written in any language. It's totally language agnostic. And it was open sourced originally by Facebook back in 2015. So let's talk a little bit about what it looks like in function. The menu, when you order your food, what menu is available, that in the GraphQL world is the schema. We call it the schema. It's defined by Surprise, surprise. The schema definition language defines the schema. Your schema describes the shape of your available data. So in the sample schema I provided on the left, this is like, imagine that you're like, there's customers, like the database basically is tracking, you've got customers, the customers place orders, each order has products that are part of the order, and then at the bottom you can see a query, because as part of your schema you also define how you request the data, and that's what the query definition is. You also have mutations. I didn't put it in the sample, but the mutations are what they sound like, right? You're gonna make some modifications to the data. The closest thing, the parallel in REST, is the API spec. It's an API specification. It's very similar. Now, about placing an order, which is your query, right? You only order what you need. I think I've said that 3 times already, and we've only been going for like 8 minutes. So the order is the query. Note that in this example, I haven't asked for all the fields available. So this is the query on the left. It's just an alias at the top. The red thing, it says get customers. I'm asking for the customers fields, and then under the customers field, I'm asking for the ID and the name fields only. I only want those properties. If we go back to the schema again, you can see that it also has an orders field, but that has a lot of data in it. I don't really need, I just need that surface level customer data for this query. So I'm only asking for ID and name, and so my query will only request ID and name. The value that is returned on the right then is only giving me what I asked for, right? No more, no less. I actually, well, let's see if I can crane my neck far enough. I was hoping to demo just like a little toy service that I have. Oh God, I can't even see the tabs. Okay, this might be hard. Here we go. Maybe, can you all see that? Okay, so this is a, I guess you call it a GraphQL IDE. This is called GraphQL, if you want to call it that. It's open source. And you can see that I'm making the same query, and I just ran it, and you can see the like mock data that I populated into it. It's exactly the same as on the slide. If I could crane my neck harder, I would show you what it looks like in Postman too. But in Postman, everything, if you're querying a GraphQL service, it would just be a post, and then the body would take the query, and it would just return your value. Also, everything, by the way, while we're talking about this, your post request is always going to return a 200. It's always going to be a success. And so error handling in GraphQL also looks very, very, very different. It's all like in the body in the return response. Okay, I'm going to come back to the slides, if it will let me. Oh my God. Here? Here? Here, okay. That's not what I wanted. Oh God, I wasn't expecting such a big. Where's the present button? Where's the present button? Oh, it's over there. Oh my God. Yeah? Okay. That works. All right, so I think the next reasonable question to ask is, okay, I have my schema, I know how queries work. How does it all, like I'm a service developer, how do I actually connect things, right? In REST, we have your spec, you have your controllers. The controllers are basically defining the business logic. And so the same thing is true in GraphQL services as well. Instead, we call them resolvers. Intuit is a Java shop, which means that we write all of our resolvers in Java. But like I mentioned, it's language agnostic. You can use whatever you want. Because we're a Java shop, though, we use a library by Netflix, also open source, called DGS. It just handles all of the like boilerplate code generation stuff for us. If I have a schema, for example, DGS will help me take the schema and like compile it, and then it creates a whole bunch of objects with fields in them that like match the schema. There's some things you can do to configure these. You don't want to expose all your fields from the schema. This is like a basic security principle for GraphQL. But it makes our lives easier as developers when we write these resolvers. So let me just walk you through this one really quick. On the left, we have the schema. It's like a minified version of the schema. On the right, we have a resolver example just for one of the queries on this schema. So I had previously, so there's actually 2 queries here. There's customers and then there's customer by ID. Over here, we're defining specifically the annotation here, DGS query, is tying the customer by ID method directly to that query. So it's by name and annotation. It's taking in an input argument, string ID, which matches the types don't match. Okay, should have caught that, my bad. I have it as an integer over here. It's okay, it's taking an ID and then it's returning, it's very simple, right? It's just going through the data access object and then finding the customer by ID. So this is just pseudocode basically to show you how it all wires together. But the whole point is that because we're using DGS, there's like very little code that we have to write actually for many of our resolvers, especially the simpler ones. Okay. Now, let's talk about something we haven't questioned until now, which is that in my analogy, you're going to the food court, suddenly there's one cashier instead of three. How did those menus get combined exactly? Like at first it feels like it's a really easy, obvious thing, but like what if, right? What if multiple of those shops sold hamburgers? Like how would I know whose hamburger I was ordering? This is just one example of many problems when it comes to combining schemas together. And this is one of the biggest problems, actually. We've been in a raging debate. It's a little dramatic, but there's been an ongoing discussion in the GraphQL community about how we put these schemas together and make sure that they function, don't clash with each other. Like, are there naming conventions we need to establish? There's so many different ways you can combine schemas. The two most popular, I would say, are schema stitching and schema federation. These are the two approaches. We have run the gauntlet with this one at Intuit. We started with schema stitching. We had our own in-house schema stitching solution, and then we shifted into federation. So that's our current journey that we're going through. But to talk you through what they are, schema stitching is some people call it a monolith solution. It's basically where, in our analogy, right, each of those three shops would have just given their menus, like they have their menus set to be as clear as they possibly can get it. They give those menus to the cashier, and then the cashier kind of has their own system, their own algorithm, their own way to put all of the menus together and make one centralized menu. So they centrally handle that. This requires that each of those menus is like very clear and makes sense, which I think any REST user will know that it is not always the case, that every REST spec you've ever worked with is clean and functional. So it does require that much. But schema federation asks something different. Schema federation is decentralized. So essentially, it's creating like we introduced the concepts of supergraphs and subgraphs. It would introduce a new supergraph that overarches over all of the subgraphs and then combines them together into one new supergraph schema. So this one is more decentralized because it requires a lot of standards to be set and then followed by the participating subgraphs, because they're sort of like each of them following the rules so that everyone's schemas can safely come together. And each of them is enabled by like different sets of open source. Most people are using these open source libraries. On the top for schema stitching, it's mostly through GraphQL Mesh, and Hive is the like schema CDN is how you can think about it. I know I named GraphQL in there because that's our in-house solution. We've open sourced it as well if you're curious to check it out. And then under schema federation, which is starting to pick up more steam recently, the Apollo GraphQL platform is what mostly manages that. Okay, so now that you know what GraphQL is, I'm assuming you already knew what REST was. How do you choose between the two? Like what's the difference then, really, functionally? Because I think the way I've presented it, GraphQL sounds kind of ideal. So let's talk some of the pros and cons. First, for REST, I think we all know REST isn't perfect, but it works. It works really well, actually. We've been using it for so long, just like as a tech industry. It helps that it's familiar. The most important thing about an API is that people know how to use it, right? Like you're not gonna bombard me with questions as basic as like, wait, how do I call this? Like, the GraphQL world is still like that. People are like, I literally don't know how to call a GraphQL endpoint. Like, I don't know how. We do not have this problem with REST. People can figure it out. The familiarity is so important, especially if you're selling a third-party API. Your third parties have to know how to use your API. So this point is really hard to debate, actually. It's also predictably scalable. If someone, let's keep using the analogy, if someone walks up to the hamburger shop, they want hamburgers, you can sort of predictably guess that they're probably going to order like a hamburger, or at least in units of hamburgers. You know by the number of orders they're making how many hamburgers they want. Versus if someone walks up to that central cashier, you don't know, do they want hamburgers? Do they also want pizza? Maybe also a hot dog? Like, I don't know. Maybe there's sushi over there. Like maybe they also want sushi. And so when someone is asking for something or ordering something, in our analogy, you don't know how large that order is going to be. GraphQL is less predictably scalable than REST is for that reason. Let's skip over to the cons. I've mentioned a lot already over and under fetching, so I'm not going to keep talking about it. But I also think it's important. I'm a former front-end dev myself. One of the biggest pain points of REST, and it's just a reality that we never questioned, was that like you just have to wait. Even if you set the most robust contract between the back end and the front end, most of my development work was contingent on the backend services actually being ready for me to start building the front end on top of it. So this is a little different in the GraphQL world. Let's go ahead and talk the GraphQL pros and cons. So again, over underfetching, y'all got the gist of that already. The cross-domain data stitching, I mentioned the schema composition thing. I should mention actually for the data stitching part, there is a working group, like a schema. It's called the Composite Schemas Working Group. Intuit is actually a member of that working group. And if you would like to get involved, they are still working on setting some kind of a standard that isn't, I mentioned like schema stitching, Apollo Federation. There's a lot of problems that we're still trying to resolve. And so the Composite Schemas Working Group is actively crunching that out. If you want to participate, they are always open. We are at an open source conference, so hopefully that's the mindset here. Let's see, I mentioned earlier the dependency on API devs, and it is a just easy drop and replace backend for front end replacement. Let's see. The load traffic we also mentioned earlier, and then something to bring up also is that migration tends to be a little easier with GraphQL. Versioning on the client side is a little different, but at least producer side, API producer side, migration, or rather I should say, I was thinking about something else. This complexity of migration is more about adopting GraphQL. Hard, as I imagine, based on everyone here not knowing GraphQL. So the adoption curve is a huge challenge. For us, the fact that like half of my job is shilling GraphQL, I think says a lot, especially even to our internal developers, our own developers. They literally work for Intuit, and I still have to convince them. So not the easiest thing. And I mentioned throttling and authorization here because it's its own very specific can of worms in the GraphQL space. I'm not an expert on this. The last time I presented these slides, I had the authorization expert with me. So I'm not going to get into the nitty gritty, but I do recommend, if that's a concern for you, looking into it before you make your decision. Okay. That's pretty much it for the big notes. I leave you with some dessert. So I have a link tree over here. It's just my personal link tree. If you scan it, I've deleted all my other links. So these are the only links on it right now. I'm going to talk you through a little bit of these. The first one is a blog post that Intuit published actually on Dev2. It's just out there. It just walks you through step by step like a workshop of the first time you ever want to set up a GraphQL service, a JavaScript-based GraphQL service. Step by step, copy paste the code, it'll work. Second one is just the standard GraphQL.org, GraphQL Foundation learning pages. I found that they're quite good, actually. There's a few tutorials you can follow. DGS I've mentioned before for the Java Spring Boot. Oh, I didn't think I mentioned it was It's Spring Boot for the Java resolvers. And then if you're familiar with awesome lists, there's a good awesome GraphQL list on GitHub. I mentioned the IDE also. That's the second GitHub link, GraphQL. Schema stitching versus federation, I mostly learned from like one blog post. It was a great blog post, so that's what that link is. And then finally, I wouldn't talk that much about client side, right? But GraphQL clients are mostly nowadays, most people are using Apollo client. You can also just use Fetch API if you want to, but there's reasons people use Apollo client. And there's a good client comparisons. This is a GitHub gist if you want to read up more on it that someone else wrote. I also really liked it. I will say that at Intuit, when the GraphQL versus REST question panned out, we've settled it now internally. And for us, it's, if you're familiar with the terminology, I believe it was north-south is client service traffic. For that one, we use GraphQL. And then for east-west, which is service to service, we use REST or gRPC. We just found that this was the most efficient way for us to solve this problem. We don't want to abandon REST. That was never the goal. But we do want to use GraphQL to optimize wherever we can. And especially as a massive organization, we have 7,000 plus engineers and a lot of services and data. It was, for us, the best solution. And of course, we're still on a migration path too. It's not one stop to freedom. So we're still working on it as well. All right, that's pretty much it.